A very good morning to all of you. I, Neha Yadav, Assistant Professor in ABES Engineering College, is going to take lecture on page replacement algorithm. In this lecture, I will cover least recently used page replacement algorithm. The content of this lecture are Introduction to Page Replacement Algorithm, Introduction to Least Recently Used Page Replacement Algorithm, and the last topic is Gate Question of Page Replacement Algorithm. What is page replacement algorithm? In operating system that uses paging technique for memory management, page replacement algorithm are needed to decide which page needed to be replaced when new page comes in. So we use page replacement algorithm to decide which page needed to be replaced when a new page or when a new page is referred from the CPU. Whenever a new page is referred and not present in memory, page fault occurs and operating system replaces one of the existing pages with the newly needed page. Different page replacement algorithms suggest different ways to decide which page to replace. The target of all is to reduce number of page fault. The three different types of page replacement algorithms are first in, first out page replacement algorithm. The second page replacement algorithm is least recently used page replacement algorithm. And the third page replacement algorithm is optimal page replacement algorithm. In this lecture, I will teach the second page replacement algorithm, which is least recently used page replacement algorithm. So coming to least recently used page replacement algorithm, in least recently used page replacement algorithm, the page to be replaced is the least recently used. When we need to replace a page, we will choose the page to be replaced. We will choose up the page which is least recently used. We will understand this algorithm by using a simple example. This is the page reference string. The string contains these values 7012030423032. We will solve this question using 4 memory frames, or we can say 4 page frames. The string is given in the question. We have to find the number of page faults. So the first value is 7. And if we see here, there are 4 frames of the memory. The first frame, second frame, third frame, and fourth frame. These are the 4 memory frames. Initially, all memory frames are empty. So we have to insert page 7 to the memory. So as initially memory is empty, there is no page in the memory. So we can use first slot of memory to insert these page 7, and then in next value is 0. So 7 was already present in the memory. We will insert next value, which is 0. Now the next value is 1. So 7 and 0 are already in the memory. Next value we will insert is 1. The next value is 2. So 7, 0, 1 are already present. There is still an empty frame in the memory. So we will insert 2. Now the next value is 0. So 0 is already present in the memory. So we will not replace any page. This is a page hit. When we find a page already in the memory, it will consider as page hit. When the page which we require is not in the memory, it will be a page fault. We will replace page fault with a F. 7, when the page referred is 7, it is not present in the memory. We stored it in the memory. It is a page fault. 0, it was not also in the memory. So it is also a page fault. 1 was also not in the memory. So it is also considered as a page fault. 2 is also not in the memory. So it is also considered as page fault. But 0 is in the memory. It is present in the memory from. So we will not swap any page, or we will not replace any page. We will copy the pages as it is, and we will consider it as a hit. The next page which is referred is 3. So 3 is not present in these memory frames. So we have to replace. Now for replacing, we have to choose one page to replace and insert the value 3 in the memory. So out of these pages, we have to choose a page which we will replace with 3. So how we will choose the page from these existing pages? For this, we will use least recently used page replacement algorithm. So out of these four page frames present in the memory, we will see which page frame was least recently used. So now we will check 2 was one value before 0. And what about 1? 1 was before 2, then 0, and then 7. So the least recently used, matlab the least recently used page is 7. So we will replace 7 by 3. 3. 7 is replaced with 3. 7 was the least recently used page. So we replace 3, 7 with new page 3. The next value is 0. Now we have to, the value referred is 0. 0 is already present in the memory. So we will copy as it is, and it is a page hit as 0 is already present in the memory. 3 was not in the memory, so it is a page fault. Next value is 4. We will check whether 4 is in our memory frame. It is not in our memory frame. Now we will see which page we have to choose to replace it with 2. So the least we are using least recently used page replacement algorithm. So we will choose which page out of these 4 pages was least recently used. So 3 was used just before this page. 0, 1, 2 out of 0, 1, 2. 0, 1, 2. If we see out of 0, 1, 2, 1 was the least recently used page. So we will replace 1 with 4. This is also a page fault as 4 was not in the memory frame. Next value is 2. 2 is present in the memory frame, so it is a page hit. Next value is 3. 3 is also present in the memory frame, so it is also a page hit. Next value is 0. 0 is also present. Next value is 3. 3 is also present in the memory. It is also a page hit. Next value is 2. So 2 is also present in our memory frame. It is also page hit. So we will count total page hit. So total page hit are 1, 2, 3, 4, 5, 6, and 7. So total page hit are 7. And total page fault, we will count the page fault here. The total page fault are 1, 2, 3, 4, 5, 6, 6. So total page fault are 6. Now we will calculate hit ratio. The formula for hit ratio is total hit divided by total values. So here there are total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 values. 13 values. So the formula, I will write the formula again. Total hit divided by total values into 100. This is the hit ratio. If we are asked to calculate fault ratio, then the formula for fault ratio will be total faults divided by total values into 100. So by to calculate hit ratio, the hit ratio is total hit values upon total values into 100. If we do this, the total hits are 7. 7 divided by 13 into 100, we will get 53.84. So this is the least recently used page replacement algorithm. Now we will consider a gate question of least recently used page replacement algorithm. So here the reference string is 1, 2, 1, 3, 7, 4, 5, 6, 3, 1. we will use, in this question, we will use 3-page frame. We have to find the number of page faults. So as in last question, we will start as initially our memory is empty. So we will allot a memory frame to the referred page. So there is as the first memory is empty, we will allot the first frame to the memory. Again, we have empty slot in the memory, so we will allot 2 to the memory. Next, we will allot, next value is 1. So 1 is already present in the memory. So this is a page hit. It is already present in the memory. Next value is 3. Next value is 3. So still we have a empty memory frame. Sorry. This is 2 and this is the empty memory frame. So we will insert 3 to the memory frame. This is a page fault. Next value is 5. Sorry, 7. So now we need to replace a page with 7. So which is, we are using least recently used page replacement algorithm here. So out of these 3, we have to select least recently used page. So out of 1, 2, 3, which is the least recently used page? 3 is the just before the 7 and then 1. So least recently used page is 2. We will replace 2 with 7. So 7 is replaced with 2. Sorry, 2 is replaced with 7. And this is also a page fault. Now the next value is 4. 4 is not in the memory frame. So we again have to replace the least recently used page. So which is the least recently used page out of 1, 7 and 3. So out of 1, 7 and 3, 1 is the least recently used page. So we will replace 1 with 4. This is also a page fault. Next value is 5. So again, we have to choose the least recently used page out of these 3 pages, 3, 7, 4. So 3 is the least recently used page. We will replace it with 5. This is also a page fault. Next value is 6. So again, 6 is not in the memory frame. So we have to replace 1 page out of these 3 pages to replace the value, to insert the value 6. So out of 5, 7 and 4. 5, 7 and 4. 5, 4, 7 is the least recently used value. We will insert 6 in place of 7. This is also a page fault. The next value is 3. So we will check, is 3 present in the memory frame? No, it is not present. So we have to replace 1 page out of these 3 frame to insert the page 3. So we will select the least recently used page out of these 3 pages, 5, 6 and 4. So 6 was the most recently used, and before that 5 was used, and before that 4 was used. So we will replace 4 and replace 4 with 3. This is also a page fault. The next value is 1. So 1 is also not present in the memory. We have to replace one of these value with 1. So we will find least recently used page out of these 3. So 3 was the most recently used page. Before that we used 6 and the last one was 5. So we will replace 5 with 1. So this is also a page fault. If we count total number of page fault in this question, the page fault is 1, 2, 3, 4, 5, 6, 7, 8, 9. So the total page fault was 9. And if we are asked to calculate fault ratio or hit ratio, so if we are asked to calculate fault ratio, it will be 9 divided by total number of values in the string 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is 9 divided by 10 into 100. So it is equals to 90%. And the hit ratio will be, the total number of hit in this question are, there is only 1 hit. So 9 fault and 1 hit. So total hit ratio is 10%. So this is least recently used page replacement algorithm. Summarizing this lecture, we studied three topics in this lecture. The first one was what is page replacement algorithm? Page replacement algorithm is needed when we use paging technique in memory management. Using page replacement algorithm, we decide which page we have to replace when we need to, when a different or new page is referred by the CPU. So page replacement algorithm is used to find which page is to be replaced by the new page. The second topic was least recently used algorithm. Least recently used algorithm says that the page which is least recently used should be replaced when a new page is referred. And one example of least recently used page algorithm is discussed, and after that example, a gate question is discussed. That's all for least recently used page replacement algorithm. These are my references. I take reference from the Galvin book of operating system. This is the disclaimer. Thank you. Thank you so much.